Hi friends, here's your geometry videos for those of you who need a review and also for those of you who weren't here last week. We only covered 2 sub-chapters. We're going to go one by one really fast and do a quick review. I don't think that both Jack and Manny missed a lot in class because this is all basically Algebra 2. But let's go ahead and review what we did. We mainly talked about slope. And then we took that concept and applied it to parallel and perpendicular line. But let's do the review of the slope first. So we remember how we learned this in either Algebra 1 or Algebra 2. Both of them, you've learned this before. Slope represents the inclination of a line. So if I keep this calculated like this, the incline, how steep or not steep the incline is, represents the slope of a line. And it has 2 formulas. One is very easy. It's rise over run. So if you know how much from the first point to the second point you go straight up over how much you know you go over, then it's an easy problem to solve. So in this case, I had the rise over run. The rise is 4. The run is 10. All I have to do now is reduce this fraction. This becomes 2 over 5. And that's my slope. When they give you the rise and they give you the run, all it comes down to is reducing a fraction. The other formula that is incredibly important, and I said this in class a lot, is the formula of the actual slope, which is if they just give you 2 points and they want you to find the incline of that line that they form or the slope, it's going to become y2 minus y1 over x2 minus x1. And I said this in class, I'm telling you this again. For your homework, mainly for your test, I need to see this as you work it. I'm on page 165 and we're going to work the 2 points 0, 6, and 5, 2. And they're saying, go ahead and find the slope of this. This is what I need you to do. x1, y1, x2, y2. I don't care if you just put this first point and that becomes second point. I want to see the name of them. Because once you name them, you'll get that slope correctly. So this becomes m equals y2, 2, minus y1, 4, over x2, 5, minus x1, 0. This is negative 4 over 5. And that is our slope, negative 4 over 5, okay? And we've done a lot of problems like this where we just use points. I'm going to make another one up just for us to remember how to do this. One more example of a slope would be, I don't know, 2, 5, and negative 3, 7. I have no clue. I'm making it up, okay? The slope, first of all, you're going to go x1, y1, x2, y2. If this is your first point, the coordinates will have a 1. Second point, the 2. My slope equals y2, 7 minus y1, 5, all over x2, negative 3 minus x1, 2. This becomes 2 on the top over negative 5 or negative 2 over 5. Okay, and I'm going to do one more example just because I feel like we want to cover this part of it. If I am telling you that the first point is negative 3, 0, and the second point is 0, 9, again, x1, y1, x2, y2, my slope is 9 minus 0 over 0 minus minus 3. Remember, this minus is not that negative, okay? This becomes a positive. This is 9 over 3 or 3 over 1 or 3. Either one are fine. That's how we do slope. Once we've talked about the slope, we did a quick review of the slope-intercept form of a line, which is y equals mx plus b. And the type of problems that you run into, it says, find the equation of a line that has a slope of 5 and it goes through the point 2 and 3. What is the equation of a line that has a slope that is 5 and it goes to point 2 and 3? Well, we're going to work with this over and over again. This becomes y equals, my m, I know it's 5, x plus b. If you notice, what we are missing is that b. We don't know the y-intercept. But we have this point, which has an x and it has a y every single time, which means this x is going to come in here. The y is going to replace that y. And that way we can find our b. So this becomes y, as in 3, equals 5 times x, as in 2, plus b. 3 equals 10 plus b, minus 10 minus 10. b equals negative 7. So my final answer, don't ever stop here. My final answer, the equation of a line that has this slope and goes to that point is y equals 5x, I know the slope, plus b, which b is minus 7. You can write plus -7 or minus 7. And now I have the equation of a line. So there's 2 steps when you have a problem like this. Step 1, you plug in your slope. And now you look at this and you go, I need my y-intercept. I'm going to use the given point to me, 2 and 3, to use as x and y in order to find my b. And then I have the equation of a line where I have a slope and I have a y-intercept. So this is the quick Algebra 1 review. Let's try another one just for the sake of it so that you will see another practice problem on this. Let me find another problem that is in here in your book. Here it is. It is write the equation of a line that goes through -3 and 9 and has a slope of -1. Again, step 1, all we have to do is replace that slope. Y equals -1x plus b. Now that I have this, I know I need my y-intercept. This is my x, this is my y. I can just go ahead and substitute them. 9 equals -1 times -3, which is my x, right? Plus b. Remember, your first coordinate is always your x, your second coordinate is always your y. 9 equals 3 plus b, -3 minus 3, b equals 6. I can now finish this by writing the equation of a line. Y equals -1x plus 6. And I got the equation of a line. This was the quick review of just the line. And then we applied what we just learned to parallel and perpendicular lines. So I'm going to go ahead and erase this. And I'm going to go ahead and split the table in half. The table, oh my gosh, the board in half. And we're going to work both of them. The first one is going to be the parallel lines. And we said in class, parallel lines have the same slope. They both have the same. And it kind of makes sense. Because if they're parallel, then their inclination is the same. And we said slope is inclination, right? Their inclination is the exact same. They don't meet, so their slopes are parallel. So, for example, on example 3 on page 166, it says, find the slope of each line and figure out if they're parallel. And this was the easy one. The first line has a rise of a 4 and a run of 2. That's my first slope, which is 2. The second line has a rise of a 2 and a run of a 1, which is 2. Yes, the lines are parallel. 2 equals 2, the lines are parallel. Example 4, on the same page, after example 3, it gives you 3 lines. And we're going to do the exact same thing. Let me write the points down. -6, 5. And then 4, 0, I think. Or -4, 0. -4, 0. Let's find the slope of the first line. This is the blue line as you look in the book. And 1 equals 0 minus 5 over -4 minus -6. And remember what I've asked you. I want to see this over and over again. This is -5 over 2. For the second line, which is the red line, I have -2, 6, and 0, 1. x1, y1, x2, y2. My second slope is 1 minus 6 over 0 minus -2. -5 over 2. Clearly, the blue and the red line, which they have lines, are parallel to each other. Let's see the third line. Let me go ahead and separate them so you see what's going on. So I'm looking at we did the green. Oh, the first one is the green. I'm sorry. We did the green, we did the red. We're going to do the blue. 0, 6, and 2, 0. 0, 6, and 2, 0. x1, y1, x2, y2. My slope 3 is 0 minus 6 over 2 minus 0. -6 over 2, which is -3. Only the green and the red lines are parallel. Why? Because their slope is equal to each other. So that's how you check if 2 lines are parallel. You calculate that slope and you make sure it's equal to each other. The next type of problem we talked about parallel lines was write the equation of a line that goes through 2 and 3. So I know it goes through that point. And it has, oh, we already did this. I'm sorry. It goes through the point, let me write this. It goes through the point 3 and 2, sorry. and it's parallel to the line y equals negative 1 over 3x minus 1. So there's two things that I know about this line. First of all, it goes through this point. And second of all, it's parallel to this L1, which is like this. If two lines are parallel, they have the same slope, which means for my line 2, which looks like this, y equals mx plus b, every single time, the slope is the same. All I have to do is come and plug in the slope here. So this becomes y equals negative 1 over 3x plus b. From this point, it's just what we did a second ago. We have a point. There's my x and there's my y. They get replaced. Y, 2, equals negative 1 over 3 times x, 3 plus b. This gets reduced. 2 equals negative 1 plus b, plus 1 plus 1. B equals 3. So I can now write the equation of a line being y equals negative 1 over 3x plus 3. This line and these lines are both parallel. How do I know? Their slope is equal to each other. So when you have problems with a line goes through a point and it's parallel to another line, all you have to remember is the slope, the number in front of x, stays the same. So you already know my m2 is negative 1 over 3, which means now I can go ahead and replace it in here and continue and work the exact same way we worked them before. And this is really all we've done about parallel lines. And when it comes to perpendicular lines, I'm going to go ahead and erase this now. And we're going to talk about perpendicular lines and slope of perpendicular lines. Parallel lines, slopes are identical or the same. For perpendicular lines, I can't spell this. The slope are opposite, reciprocal. So if I will tell you the first line has a slope of 2, what is the slope of the line perpendicular on it? It would be the opposite. This is a positive. The opposite would be a negative. And reciprocal, we flip that number 1 over 2. If the first slope is negative 2 over 3, and I'm asking you what is the slope of a line perpendicular on this line, then my second slope would be the opposite, which makes it a positive. You can write the plus or not write the plus. Reciprocal, 3 over 2. So every time you think of perpendicular, you think about I need to change the sign of the first slope and I need to flip that number. And so we have problems like this. We are on page 172, and example 1 says find each slope. We have two lines. The first one is negative 4, negative 3, and 0, 3. The second line is 0, 3, which is the red one, and 3, 1. And it says find the two slopes, and then decide if the two lines are perpendicular. Well, again, I'm sorry, Talia, if you're watching this, you have to do this. My slope 1 is 3 minus minus 3 all over 0 minus minus 4, right? 3 minus minus 3, 0 minus minus 4. This is a plus, this is a plus, this is 6 over 4 or 3 over 2. Let's find this one. My second slope, again, x1, y1, x2, y2. 1 minus 3, 3 minus 0. See, as soon as you get them written down like this and you go y2 minus y1, x2 minus x1, it comes easier. This becomes negative 2 over 3. Let's look at the two numbers. Are they opposite, reciprocal? One is positive, one is negative, one is negative 2 over 3, one is positive 3 over 2. Yes, the two lines are perpendicular. I'm going to skip example 2. It's the exact same way. They give you two lines, you find the two slopes, you look at them, are they opposite, reciprocal? Example 2 says, yes, they are. One slope is 2, the second slope is negative 1/2. The lines are perpendicular. The last type of problem that we worked in this subchapter was, well, actually we had two problems that we worked, so let's work both of them. Decide if the lines are perpendicular. You have 4x plus 5y equals 2, and 5x plus 4y equals something else. Let me remember, 3. You cannot decide by looking at them like this. We have to get back to that form y equals mx plus b every single time. You need to get to this form. So my first move is to get rid of this negative 4x. I'm going to move it on the other side. And if you did not do math with me, you didn't hear me say this, but if you did, you will remember. X comes first, so this is negative 4x plus 2. Don't put that on the back. This is your first term, that negative 4. And then all I have to do is divide the 5. So just go ahead and divide the 5 individually everywhere. You end up with y equals negative 4 over 5x plus 2 over 5, which means the slope of this line is the number in front of x, negative 4 over 5. Let's see what we get on this one. Again, minus 5x minus 5x. I just need y alone. 4y equals negative 5x plus 3. That comes first. Then I divide the 4 out in each place separately. Y equals negative 5 over 4x plus 3 over 4. Which means my second slope is negative 5 over 4. If you look at the two numbers, they're definitely reciprocal, but they're not opposite, which means no, they are not perpendicular lines. In order to decide that two lines are perpendicular, you have to bring them to this form. So then you can identify they're both slopes and say, are these slopes opposite reciprocal? No, they're not. They are reciprocal, but not opposite. The two lines are not perpendicular. And now the last type of problem we worked is the exact same type of problem with what we worked with parallel lines. As in, you're going to get the equation of a line, you're going to get a point, and you're going to have to figure out what is the equation of the line perpendicular on that first line. Example 5 says you have line L1 that has y equals 2x plus 1, negative 2x plus 1, sorry. L2 is perpendicular to L1, so we know this, and it goes through the point 4, 0. Find the equation of the line L2. Well, first of all, L1 has a slope of negative 2. Please remember, I say this a lot. The slope is just the number in front of x. Do not include x in there. That's your slope. That negative 2 tells you the inclination. If I know the two lines are perpendicular, then my second slope has to be the opposite reciprocal. Opposite reciprocal. Now I have a point and I have the slope. We're starting with y equals mx plus b. I can go ahead and replace this. Y equals 1 over 2x plus b. Here's my point. X, y. 0 equals 1 over 2 times 4 plus b. If you're wondering where, 0 comes from here. That x is now 4. 0 equals 2 plus b. b equals negative 2. Why? Because I need to minus it on both sides, right? So my final equation of this line is y equals 1 over 2x minus 2. And if you ever wonder, you look at these slopes and you go, are these opposite reciprocals? Yes, they are. So these are the equation. This is the equation of a line that's perpendicular on that line. And this is about all we did in class. We also worked example 6, which is the exact same thing. And this, I'm going to go ahead and, while I didn't really want to do it, I'm going to do it just because Jack and Maddie were not in class. If you were in class and you feel like you're done and you know what you're doing, stop right here. If you feel like you need one more helper, here it goes. You have the L1, which is 3 over 2x plus 1, I think, plus 3. I keep making up stuff. And then it says the two lines are perpendicular. It's about a ray that's perpendicular to something else. And it goes through the point negative 2 and 0. Find the equation of that ray that's perpendicular. That's what they're looking for. So for my first line, the first thing I want to do is find my slope. And we said the slope is always the number in front of x. It's 3 over 2. which means for my second line, it's going to be opposite reciprocal. This is a positive, so it becomes a negative. Reciprocal is 2/3. That's where we are. Let's go ahead and find the new slope. The new equation, I'm sorry. mx plus b. Here's my slope. Y equals -2/3 plus b. Here's my x, here's my y. 0 equals -2/3 times -2 plus b. Nothing reduces. 0 equals a negative times a negative is a positive. 4/3 plus b. All I have to do is minus the 4/3 on the other side, which means b equals -4/3. Now I can go ahead and finish this line. Y equals -2/3x minus 4/3. This is the equation of the line perpendicular on that line. So really there are a few steps. First, you have to identify your first slope. Then, if the lines are parallel, the slope stays the same. If the lines are perpendicular, you need the opposite reciprocal. And then you have to remember that the point they give you, you're going to replace in the place of x and y to find your b or your y-intercept. Once you have all that, you plug it all back in and you have your answer. So yeah, that's what we did in class. Happy testing. Please, please, please write me the x1, y1. It's not here now. y2 and x2 so that I know you have a good grasp of that. And then I'll see you a week from today.